Welcome back to the deep dive where we dive deep into a new topic every week.
Always exciting to see where we end up.
That's right. And today we're headed to Oak Ridge National Laboratory,
Or ORNL.
ORNL,
Yeah.
to explore a fascinating piece of nuclear history, the Molten Salt Reactor Experiment, or MSRE.
The MSRE, yeah, it's a really different approach to nuclear power.
Different how?
Well, most people, when they think about nuclear reactors, they think about solid fuel rods, right?
Right.
But the MSRE, this was liquid fuel,
Molten
dissolved in molten salt.
salt. So no fuel rods at all.
Nope.
Wow, that's pretty wild.
Yeah.
It ran for about 4 years, 1965 to 1969. What made it so unique?
Well, the molten salt, it wasn't just a carrier for the fuel, it actually acted as both the fuel and the coolant.
So the same molten salt was both powering the reactor and keeping it cool.
Exactly. Pretty ingenious, right?
Yeah, that's some serious multitasking. I read that it ran for thousands of hours at high temperatures. How did they even prevent corrosion with molten salt at those temperatures?
That's actually one of the things that made it so successful. They really tackled that corrosion challenge.
I bet Alvin Weinberg was pleased.
Oh, he was a huge proponent of the project. He even jokingly called it the mighty smooth running experiment.
Mighty smooth running experiment.
Yeah.
I love that. Okay, so clearly Weinberg saw a lot of potential in this technology.
He did. He really believed that it could help solve some of the world's big energy problems.
What did he think it could solve?
Well, theoretically, it wouldn't be susceptible to meltdowns, and it could even consume nuclear waste from conventional reactors.
Okay, so if it was so groundbreaking, why didn't it become more widespread? Why don't we see molten salt reactors powering our homes today?
That's a great question, and it's a bit of a complicated story. To really understand it, we have to look at the technology, the politics, and the scientific priorities of the time.
It sounds like the MSRE has a pretty interesting backstory. Before we get into all that, I'm curious about how ORNL even got involved with molten salt reactors in the first place.
You know, it's actually kind of a funny story. It all started with the Air Force.
The Air Force? What do they have to do with molten salt reactors?
Well, back in the 1950s, they had this vision,
Whoa.
a nuclear-powered aircraft.
A nuclear-powered aircraft, like a plane.
A bomber, actually, one that could stay airborne for really long periods.
Wow, that's some serious sci-fi stuff. So how did ORNL get roped into this?
Well, the Air Force needed someone to develop a reactor that could handle the extreme temperatures needed for jet propulsion. So they turned to ORNL, which was already known for its nuclear expertise.
Makes sense.
Mm-hmm.
So we're talking about temperatures way higher than a typical nuclear reactor.
Oh, yeah, way higher, like 860 degrees Celsius.
860 degrees Celsius, isn't that almost as hot as molten lava?
Pretty close. And that's where the idea for the molten salt reactor came in. Conventional water-cooled reactors just couldn't handle that kind of heat.
So the pursuit of a nuclear-powered plane accidentally led to the birth of the molten salt reactor.
You could say that. It was really a case of necessity being the mother of invention.
And who was leading this effort at ORM?
Our friend Alvin Weinberg.
Of course, so he came up with the idea for a molten salt reactor.
Him and his team, yeah. They designed this reactor that used uranium dissolved in a molten mixture of fluoride salts. They called it the Aircraft Reactor Experiment, or R.
The R.
Did it work? It did. In 1954, they got it running. It only ran for 9 days, but it proved that a molten salt reactor could actually reach those crazy high temperatures needed for jet propulsion.
9 days? That doesn't seem very long.
Well, it was really more of a proof of concept. The goal was just to show that the technology was feasible, and it definitely did that.
And there was even an article about it in Nuclear News called Proof of Concept, the Molten Salt Reactor Experiment.
Yep. It was a big deal at the time. Remember, nuclear research was still pretty new back then. They were really exploring all sorts of possibilities.
So even though the nuclear-powered plane never took off, the ARE left behind a pretty significant legacy.
Absolutely. It might not have given us flying nuclear reactors, but it did give us the molten salt reactor concept, which had the potential to revolutionize energy production.
It's funny how that works. Sometimes chasing a seemingly impossible dream leads to something even more amazing.
That's science for you. Always full of surprises.
And in this case, the surprise was a technology with the potential to provide safe, clean energy.
Right. And while the ARE was focused on, well, aircraft,
Yeah.
Weinberg and his team started to realize that molten salt technology could be used for so much more.
Like generating electricity for homes and businesses.
Exactly. They began to envision a future where molten salt reactors could provide clean, abundant energy for everyone.
It's incredible how this project that started out with this goal of powering an aircraft
Right.
ended up on this completely different path, with the potential to, change the world.
Exactly. And that's really where the MSRE comes in.
Okay, so let's talk about the MSRE. What were its goals? How did it actually work?
So the MSRE was built in 1965 in the same building that housed the aircraft reactor experiment.
Interesting. So they just repurposed the space.
They did. And the MSRE's main goal was to prove that this liquid fuel reactor technology could really work.
So not necessarily about generating electricity for the grid at this point.
Not directly. It had a capacity of 10,000 thermal kilowatts, but it usually operated at about 5,000. It was more about studying how the molten salt fuel and coolant behaved under different conditions.
Okay, but how is it different from a regular reactor? I'm trying to picture this. Is there still a reactor core?
Oh, yeah, there's a core.
But instead of solid fuel rods...
You have this liquid fuel mixture flowing through it.
Right.
Yeah, exactly.
Wow, what was this liquid fuel mixture made of?
It was this solution of fluorides of lithium-7, beryllium, uranium, zirconium, and thorium.
And that flowed through the reactor core.
Yep, pumped through a network of channels within this cylindrical graphite core.
So the molten salt was both the fuel, creating the heat through fission, and the coolant, carrying the heat away.
Precisely. Pretty elegant design when you think about it.
It is, but I'm curious, how did they control the nuclear reaction with a liquid fuel setup?
That was one of the things that made the MSRE so impressive. They were able to control it really well. It operated for thousands of hours at high temperatures, and they never had any major issues.
So they proved that this whole liquid fuel concept could actually work.
They did. And for Weinberg, it was more than just proving it could work. He had much bigger plans.
Right. We talked about his vision for a safer, cleaner nuclear future.
Exactly. He saw the MSRE as a key step towards that future.
What were some of the specific safety concerns he was trying to address?
Well, one of the biggest concerns with conventional reactors is the possibility of a meltdown.
Right. That's a pretty terrifying thought.
Yeah, it's a worst-case scenario, but it can happen if a reactor loses its coolant.
And Weinberg thought the molten salt design was inherently safer.
He did, because the fuel's already in a molten state. There's no risk of it melting down like solid fuel rods could.
That makes sense. And the molten salt can withstand higher temperatures than water, right?
Exactly. So the risk of a steam explosion is also much lower.
It sounds like he was really thinking ahead, trying to design a reactor that was fundamentally safer.
He was. But safety wasn't his only concern. He was also a big advocate for using thorium as a nuclear fuel.
Right, thorium. Now, remind me why he was so keen on thorium.
Well, for one thing, it's more abundant than uranium.
So a more sustainable fuel source.
Potentially, yeah. And thorium can be converted into uranium-233, which is an excellent nuclear fuel.
Okay, so he saw thorium as the key to a long-term sustainable nuclear future.
Exactly. And you know what? The MSRE was actually a testing ground for this thorium fuel cycle.
Really? So they actually used thorium in the MSRE?
They did. They replaced the original uranium fuel with U-233, and it worked. The MSRE became the first reactor in the world to successfully operate on a thorium-based fuel cycle.
So the MSRE wasn't just a successful experiment, it was a series of groundbreaking achievements.
It was. It proved that the molten salt concept worked, it proved that the thorium fuel cycle worked, and it showed that nuclear reactors could be designed with safety and efficiency in mind.
It sounds almost too good to be true. And sadly, I think we both know it is.
Yeah. We know the MSRE was eventually abandoned. It's kind of a heartbreaking story, actually.
It is. I'm really curious to understand why something so promising was ultimately shelved.
Well, that's where things get complicated. We're going to have to dive into some history, some politics, and even a bit of scientific rivalry.
Sounds intriguing. I'm ready to dive in.
It's kind of funny, in a way the MSRE's success might have actually hurt it.
Really? How so?
Well, because it ran so smoothly, some people started to think that it was basically ready for prime time.
Ready to be turned into a full-scale power plant.
Exactly. But going from an experimental reactor to a working power plant is a huge jump.
And there were still those technical hurdles to overcome?
Yeah, those were definitely still there. The material challenges, the whole tritium issue, those weren't going to be easy to solve.
And I'm guessing this is about the time when funding started to become an issue.
Yep, right around then. The political winds were changing, and the Atomic Energy Commission, the AEC, was starting to shift its priorities.
So what became the new focus?
The liquid metal fast breeder reactor, the LMFBR.
Oh, right. We touched on that earlier. That was basically a rival to the molten salt reactor, wasn't it?
It was. And it had some powerful supporters within the AEC, like Milton Shaw, who's the head of reactor development.
So the LMFBR became the new favorite.
Pretty much. It was seen as this super advanced technology that could produce tons of energy.
I see. And what was so special about it?
It was a fast reactor, and it was supposed to breed more plutonium fuel than it consumed, hence the name breeder.
So the idea was that it could create its own fuel.
Basically, yeah. It
Right.
was seen as a way to create a nearly limitless supply of energy.
It sounds like the allure of all that plutonium kind of overshadowed the potential of thorium in molten salt.
Yeah, I think that's a fair assessment. The AEC poured a lot of money into the LMFBR program, and that left less money for other reactor designs, including the Molten Salt Reactor.
But I'm guessing Weinberg didn't just give up without a fight.
Oh, no, he definitely didn't. He knew that the LMFBR had some serious flaws, especially when it came to safety and the whole issue of plutonium proliferation.
Right. Safety was always a huge concern for him.
It was. So he argued that the molten salt reactor was a much better option. He said it was inherently safer because of its design and because of the thorium fuel cycle.
And thorium produces less long-lived radioactive waste, right?
Exactly. So it was a win-win, at least according to Weinberg.
Did anyone at the AEC listen to him?
Unfortunately, not really. They were pretty committed to the LMFBR, and in the end, Weinberg actually paid a price for speaking out.
What happened?
He was removed from his position as director of ORNL in 1972.
Wow, that's harsh. You get fired for advocating for a safer, more sustainable technology.
It's pretty ironic, isn't it? But that's basically what happened. And with Weinberg out of the picture, the Molten Salt Reactor program lost its biggest champion.
And LMFBR just kept chugging along.
Yep, the AEC kept funding it for years, but it turned out to be way more complicated and expensive than they initially thought.
And now we're left wondering what might have been if they had listened to Weinberg.
Right. Imagine if all that money had gone into developing the molten salt reactor instead. Would we be in a different place today when it comes to energy?
It's definitely a thought-provoking question. But there's something else I read that I thought was interesting. Weinberg himself had another theory about why the molten salt reactor didn't catch on.
Oh, really? What was that?
He wrote a letter to Glenn Seaborg, who was the chairman of the AEC at the time, and he said, "Our problem is not that our idea is a poor one. Rather, it is different from the main line and has too chemical a flavor to be fully appreciated by non-chemists."
So he's basically saying that the physicists didn't understand the chemistry involved.
I think so. Remember, this was a time when nuclear research was dominated by physicists. They were all about splitting atoms and releasing energy. Right, it was all about the physics.
Exactly. And then Weinberg comes along with this reactor that's all about the chemistry, about controlled reactions, and minimizing waste.
It was a different way of thinking, a different approach.
It was, and I think it challenged the status quo a bit too much.
It's kind of like that not invented here syndrome where people reject an idea just because it didn't come from their group.
Yeah, there might have been some of that going on. It's a reminder that sometimes the best ideas get overlooked because they don't fit into the way people are used to thinking.
So it sounds like the MSRE was a victim of a perfect storm. Technical challenges, political priorities, competition from the LMFBR, and maybe even a bit of scientific bias.
I think that's a pretty accurate assessment. It's a shame because it really was a brilliant idea.
It was. But hey, at least it proved that liquid-fueled reactors are possible.
That's true. And it paved the way for the thorium fuel cycle.
And let's not forget Weinberg's contributions to nuclear safety.
Absolutely. He was way ahead of his time in terms of thinking about how to design inherently safe reactors.
And his ideas are still relevant today, especially with the renewed interest in nuclear power.
They are. We're seeing a lot of new research into molten salt reactors and thorium-based fuels.
It's like Weinberg's legacy is finally getting the recognition it deserves.
I think so. He might not have lived to see it, but his work is helping to shape the future of nuclear energy.
Okay, so we've talked about the rise and fall of the MSRE. But there's one more thing I want to touch on before we move on.
What's that?
Weinberg's concerns about the safety of conventional reactors, the ones that actually did become widespread.
Oh, right. He was very outspoken about that. What was his main argument?
Well, he believed that pressurized water reactors, or PWRs, which are the most common type of reactor today, were chosen not because they were the safest option, but because they were the best option for naval propulsion.
You mean for submarines?
Exactly. And he thought this was a huge mistake because PWRs are inherently riskier than other reactor designs, like the molten salt reactor.
So he's saying that a technology developed for military purposes ended up shaping the entire civilian nuclear industry.
That was his belief. And he was very concerned about the safety implications.
I can see why. That's a pretty bold claim, but it makes you think, doesn't it?
It does. especially when you consider the nuclear accidents that have happened over the years.
Right. Could some of those accidents have been prevented if we had chosen a different path?
That's the question Weinberg was asking.
Mhm.
He was a big believer in inherent safety, in designing reactors that were less prone to accidents in the first place.
And that's a lesson we should keep in mind as we move forward with nuclear power.
Absolutely.
Well,
We need to be thinking about safety from the very beginning, not just trying to add safety features as an afterthought.
agreed. So what's next on our agenda for this deep dive? It's kind of ironic when you think about it.
What is?
Well, the whole idea behind the MSRE was to create a reactor that was, better at handling nuclear waste.
Right.
But then it ended up creating its own waste problems.
Yeah, that is kind of ironic. It's like we can't escape nuclear waste no matter what we do.
It's definitely a challenge. But it's a challenge we have to address if we're serious about using nuclear energy.
So let's talk about the MSRE waste.
Yeah.
What kind of waste are we dealing with here?
It's a mix of things. There's fission products, which are the leftovers from when uranium atoms split.
Okay.
And then there's activated materials, which are parts of the reactor itself that become radioactive from being exposed to radiation.
So it's not just the fuel, it's also parts of the reactor itself.
Exactly. And because it was a molten salt reactor, all of this radioactive stuff was mixed in with the fluoride salts.
And that made it harder to deal with.
Oh yeah, much harder. Molten salt is tricky to handle even when it's not radioactive.
So what was the plan for getting rid of it?
Well, the original plan was to solidify it.
To turn it from a liquid into a solid.
Right. The idea was to encapsulate it in some kind of stable form that could be stored safely for a long time.
That makes sense.
Hmm.
Solid waste is usually easier to manage.
It is. But the problem was that solidifying the molten salt waste turned out to be way more complicated and expensive than they expected.
Of course.
Hmm.
There always seem to be unforeseen challenges.
Always. And there were also concerns about whether the solidified waste would actually stay stable over the long term.
So even after they shut down the MSRE, the costs just kept piling up.
Yep, it became this huge financial burden. In the end, the cost of managing the MSRE waste actually ended up being more than the cost of building the reactor itself.
Wow, that's incredible. It really shows that the costs of nuclear energy can last for decades, long after a reactor is shut down.
It's something we have to keep in mind when we're talking about any nuclear technology. The costs don't stop when the reactor stops running.
It's a good reminder that we need to think about the entire life cycle of a technology, not just the initial development and construction.
Absolutely. We have to consider the long-term impacts, both financial and environmental.
Okay, so we've talked about the MSRE's successes, its failures, and its legacy, both good and bad. But there's one big question I still have. Knowing what we know now about climate change and the urgent need to reduce our reliance on fossil fuels, was it a mistake to abandon the MSRE?
That's the million-dollar question, isn't it? It's hard to say for sure. Maybe it would have faced insurmountable technical challenges, or maybe it would have just been too expensive to commercialize.
But maybe it could have been the solution we needed. Maybe it could have revolutionized the nuclear industry and provided us with a truly safe, clean, and sustainable source of energy.
It's definitely something to think about. We have to be careful not to dismiss potentially transformative technologies too quickly, especially when the stakes are so high.
It's a good lesson for us as we face the climate crisis. We need to be open to new ideas and willing to take risks if we're going to find the solutions we need.
Absolutely. And the MSRE, even though it was ultimately abandoned, is a reminder that sometimes the most groundbreaking ideas are the ones that challenge conventional wisdom.
Weinberg was a true visionary, and his work on the MSRE continues to inspire researchers today. Who knows, maybe someday we'll see a world powered by safe, efficient, molten salt reactors, thanks in part to his pioneering efforts.
That would be quite a legacy. And speaking of legacies, let's not forget about all of you listening out there.
That's right. We want to thank you for joining us on this deep dive into the fascinating world of the Molten Salt Reactor Experiment. We hope you learned something new and maybe even got inspired to do some exploring of your own.
Remember, every deep dive is just the beginning. It's a spark to ignite your curiosity and a stepping stone on your journey of lifelong learning. So keep questioning, keep exploring, and keep pushing the boundaries of knowledge.
If you enjoyed this episode, be sure to share it with your friends and subscribe to our YouTube channel. We're always diving into new and exciting topics, and we'd love for you to join us on the adventure.
Until next time, keep those brains buzzing.
And keep diving deep.